Hello and welcome back, guys. We're looking at activity 30.2 now. We're going to be on page 439. I just kind of wanted to run through questions number 3 and 5 that I assigned you last part. Number 3, the area I got was 5. Okay, pretty straightforward. The 2 times 5 divided by 2. And then the cost there would be 42.50 because we're doing 850 per square foot, just like from the last section. B, you get a height of the square root of 15. B has a height of square root of 15. And then when I work that out, because we're doing 4 squared minus 1 squared, so square root of 15. When you work out the area for that, you actually get square root of 15, and so the cost was $32.92. For C, that's an equilateral triangle. You get a height of 3 square root of 3, so the area is 9 square root of 3. You do 1/2 base times height, you get 9 square root of 3, and then the cost there is $132.50. For number 7, number 7 was an interesting one. That's the one where you need a geometric mean. The height is the square root of 84. Remember, you would multiply 6 times 14. That's where the square root of 84 comes from. And then if you reduce 84, 84 is 4 times 21. So 84 reduces to 2 square root of 21. All right, and so that's going to be your height with your base being 20. You add the 6 and the 14 because remember, you want both parts of that. So you would have 20 times 2 root 21 over 2. And so your final area is 20 square root of 21. Notice they say leave your answer in radical form because that's what they want. That's the better option. Okay, I am going to work through basically question number 5 on page 439. Question number 9 on page 439. I'm going to work through it on the board. You can follow along in the book or not, doesn't matter. What I have here is a generic triangle, and I'm going to show you a way to find the area of that triangle using trigonometry, using sine, cosine, tangent, that kind of idea. In fact, we're going to be using sine, but we're going to do it with the assumption we don't know what the height is, okay? So I'm going to draw my height. I'm going to go from B down here to AC, and again, this is a generic triangle. I don't know what any of these lengths are, okay? Reminder, when you're labeling a triangle, you label the sides the same letter as the angle that's opposite, but lowercase letters, okay? And so in this case, I have B here. All right, so let's talk about this. This is going to be our H, yeah? This is a right triangle if we're looking at just this section, all right? And let's say we wanted to figure out H. Well, we need something that involves H. We know we have angle A here, and we have side length C. So what we're going to use is sine. Why are we going to use sine? Well, if you remember from a couple sections ago, you had SOHCAHTOA. All right, that was the acronym to help you remember definition of sine, definition of cosine, and definition of tangent. This was my opposite length over here. This is my adjacent length here, and this is my hypotenuse. Okay. Notice I don't have my adjacent. It's part of B, but it's not all of B, so I can't really use the adjacent, which is why I have to focus on O and H, because the H is the hypotenuse over here is C, and then the opposite is actually H for height, okay? And so I'm going to use this section of the acronym, the SOH, and that's because the definition of the sine of an angle is equal to the opposite leg divided by a hypotenuse, okay? And we're going to plug in what we have. Well, sine of what angle? We're going to say sine of angle A is going to be equal to the opposite, in our case, is going to be our height, and it's going to be divided by side length C. Well, what if we wanted to solve for H? Well, algebraically, all we'd have to do is multiply by C. Remember, that's a lowercase c, so when you're writing it, keep your c nice and small. And you've got sine of A equals H. Now, you might be thinking, why in the world should we do that? Well, watch what happens here. Remember, if we're thinking formula for area of a triangle is 1/2 base times height, we know what our base is, it's B. So if my area formula 1/2 BH, right? I know my B, but I don't know my H. I can substitute. I can take this value and plug it in right here, and watch what happens. I get 1/2 B times C times sine of A. And something magical just happened. I just wrote the formula for an area of a triangle, not including the height. All I included were 2 of the sides and their included angle, okay? So think like SAS, side angle side, okay? Because remember, every triangle with side angle side that matches are going to be congruent to each other. So what this is this is a formula if you don't know the height, okay? if all you know are the outskirts. So let's do an example. Let's say we had this triangle here. Let's say this length is 10 and this length is 20. And let's say this is, we'll keep it simple, we'll do 60, okay? And let's say I wanted to know what the area of that triangle was. Well, I would do area is equal to 1/2 B, remember this was the B, so 1/2 times 20 times 10 times sine of 60, okay? Sine of 60. And then you can put that in the calculator and it'll give you your answer. And your answer is going to be a decimal. I'll give you a hint. I kind of designed this one on purpose. This is actually a special right triangle so that I know my length over here is going to be 10√3. So when I work this out, I can kind of already know what my answer is going to be. But what I would have is 1/2 times 20, which would be 10. 10 times 10 is 100. So I would have 100 times 10√3. So really what I have here is 1,000√3. That's not right. 17. Oh. Sorry, yeah, the sine of 60 is just going to be the square root of 3. My bad. Sine of 60 in your calculator would be the square root of 3. I was getting ahead of myself. I was adding an extra 10. I knew it was bugging me. So it's going to be 1/2 times 20, which is 10, times 10 times the square root of 3. So you're going to get 100 square root of 3, which is going to be approximately 171. All right? And you can check me in the calculator if you want on that. But notice what we didn't have here. We didn't have a height. Okay? And that's what this allows us to do. It allows us to work without a height, which is amazing and phenomenal and gorgeous. Okay? So here's what I want you to do. You're going to practice with that. All right? We're on page 439. You're going to do numbers 10 through 16. 10 through 16, and then come back to me and we'll go over those.